On this quick video, we'll discuss a bit more about how Shipa partners with StorageOS in order to help teams make persistent storage for applications become easy and developer-friendly. Looking at the current scenario for persistent applications on Kubernetes, we understand that many times, platforms and DevOps engineering teams are responsible for managing and providing development teams and applications with persistent storage. But as we scale our environment and applications, managing storage and volumes across multiple clusters can become complex. We also understand that teams have to spend time learning about and writing YAML for persistent volumes, persistent volume claims, how to attach it to pods, and more on Kubernetes, which also becomes time-consuming and opens up opportunities for misconfiguration and downtime of your applications and, most importantly, your application data. Not to say that today, storage on Kubernetes is not very developer-friendly, which can slow down the process of releasing persistent applications. Seeing this scenario, Shipa created a seamless storage interface where developers, DevOps, and platform teams can easily manage and provide applications with persistent storage across multiple clusters, clouds, and hybrid environments. For it to be effective, it had to be dynamic and developer-friendly, so no need to learn, write, and manage YAML files, PVs, PVCs, and others. When exploring a strong solution, Shipa partnered with StorageOS, who also shares a similar vision, and created a storage that is application-centric, where their focus is the application. It's platform agnostic, so you can run it on any cluster, and its upgrades and scaling are non-disruptive to the applications. And it's API-driven, which allows the storage to be easily provisioned, consumed, and managed through APIs. In order to bring both together, Shipa leverages its storage and volume interface, where platform operators can create one or multiple volume planes pointing to StorageOS clusters across multiple Kubernetes clusters. And developers can then create, bind, unbind, and delete volumes freely without writing a single YAML, PV, or PVC. Let's have a look at an example. Let's have a look at the environment we have here. We have our Shipa instance, where we have cluster from different providers actually tied to Shipa and its Shipa spools or landing pads. As we can see, we have clusters coming from Oracle Cloud, Azure Cloud, GKE, and we also have one cluster called StorageOS US, which is a cluster we have created on GKE. It's a 3-node cluster, and we have already installed StorageOS on it, which you can do by using Helm, and it's a fairly simple process. And we can look here and see as well the StorageOS UI for management that can be easily accessed from any of the nodes in your cluster, and you can manage your volumes, namespaces, nodes, and others. Let's go back to our CLI. As mentioned before, the first part for the volume integration and the storage integration between Shipa and Kubernetes and StorageOS is the volume plan. So if we use Shipa volume plan list, we see that right now we have no volume plans. So me as a platform engineer, let me create the first one that I can then make it available for end users, developers, and others. This can be done through the volume plan create. The only thing you need for that to work is provide this name of the volume plan and the storage class. The storage class, if we look back on Kubernetes and we go to storage classes, we can see that the StorageOS one created a storage class called fast. So we should point Shipa to that storage class. Great, easy enough, it was created. And if we list, now we see it available. Now the next step is to create a volume. To create a volume, you can do so by using Shipa volume create. And here are the arguments that you will need in order to create the volume. The first one is the volume name. So let's just call StorageOS Vol1 the plan name, which is the plan that we just created up here, called storage in this case. The pool where I want to make it available, so it's StoreOS, which is this pool here on Shipa, where we have the Kubernetes cluster pointing to it and we can see the nodes and the applications. And we can also include the capacity and the access mode for my volume, which I'll make it read write once, and the capacity we can target it as 2 gig, for example. Oops, missing the team, my mistake. So let's put the team as the admin, as the owner, because in this case I have multiple teams. Volume successfully created, great. Now, if we list the volumes available, we can see StoreOS vol1, it's created, it's pointing to our pool, belongs to team admin, and this is storage class. But right now, this volume is available at the pool level. So it's not bound to any application, which is what we're gonna be doing right now. If we list our applications, we can see that previously we deployed an application called StorageOS US. Great. So let's bind our volume to this application. So let's check the volume name. And now we're gonna bind it. Which you just need to pass the volume name, which is StoreOS vol1. The mount point, which can be the mount vol1, or you can choose. If we want to check, you can shell into the app StoreOS US. And if we list the content of our mount folder, it's blank right now. So we can just bind the volume mounting at that location. So StorageOS, Shipa volume bind, StoreOS vol1, MNT vol1, and the app name is gonna be StoreOS US. Great, you're gonna start seeing that Shipa is creating the volume automatically and attaching it to your application. If we go back on Kubernetes, while Shipa does that, and we go into persistent volume claims, and we filter it by our cluster, we can see the volume is already created and bound to our application, and this is done here. If we shell again into our app, StoreOS US, we list the content. Now we have our vol1 there in there. Basically, if I had to create that volume directly from my YAML file, the engineer, the development, or the platform engineer, or the development DevOps engineer, he would have to create the entire YAML file. I haven't created any YAML file or any single line of that. And when we go back to StorageOS UI, we can already see our volume here, created and integrated into StorageOS. And it's easy enough for any developer to do that and consume storage. If the developer doesn't need the volume anymore, he can simply use Shipa volume unbind. It's gonna ask you for the volume name. Let's just list. Then I'm gonna unbind StoreOS vol1 from MNT vol1 for my app StoreOS US. Great, the application does not see the volume anymore. And if we do a Shipa volume list, we can see that it's not bound anymore. Now the volume is available to be bound to any other application that belongs to that pool, and any other developer that has access to that pool can just bind it by using Shipa volume bind. And in case the volume is no longer needed, you can simply say Shipa volume delete StoreOS vol1. The volume is deleted automatically, and you can see that it already deleted from StorageOS's UI. And when we go back here, the volume is no longer here on my GKE cluster. So Shipa takes care of cleaning out all the objects from your Kubernetes clusters and the integration into StorageOS as well, making it easy and developer friendly for you to quickly consume and provide storage to your teams.